after the power quality tester is connected. Voltage yellow, green, red, black, corresponding to the 4 voltage terminals of ABC and of our subjects respectively. Current yellow, green, red, IBIC, corresponding to the IB of our test subjects. Also pay attention to the direction of the arrows on the side of the current clamp and the line. The actual flow direction of the current remains the same if the reverse current phase diagram changes. After connecting the wires, enter the electrical test. Check the 3-term voltage ABC. There are 3 ABCs of current, and then proper analysis. Look at the right amount. Determine whether the voltage and current are forward sequence. The only correct 3-phase and 4-wire is UA. UBUC is a clockwise angle of 120 degrees to each other. The IBICs are also clockwise at an angle of 120 degrees to each other. The wiring is correct only under this phasor diagram. If the voltage or current is reversed, we'll cause a chore in the phasor diagram. So we actually see direction the flow of current. It's face down, and then we take it upside down now. Look at the C direction current and the correct wiring difference of 180 degrees. So we need to adjust the pliers at this time. Likewise, if we voltage BC is reversed, we'll cause a reverse sequence of voltages. UAUBUC becomes counterclockwise. This is when we look at the electrical tests. You will see that term B is negative and negative power. So we are wiring on site. Be sure to connect the phase sequence of voltage and current correctly. So 3-phase 4-wire, only if this phasor diagram is correct. After checking it is correct. After the electrical parameters are also checked normally. Enter parameter settings. 3 items, 4 lines. Click again to start recording. Avoid incorrect data being recorded in this file. At the same time, we pay attention to the parameter settings. Short circuit capacity, power supply capacity, protocol capacity. Settings for these 3 items directly affects the diagonal wave voltage. Does the ramp wave of the flow exceed the standard? Impact on national standards. So we rate on the scene. It must be based on the actual situation on site. To enter these 3 capacity values, then the voltage ratio. The same goes for the current ratio. We have not gone through the voltage transformer now. It doesn't go through a current transformer either. So the voltage change ratio and the current change ratio are both 1.0. If there is a voltage transformer or current transformer, according to the actual situation on site, enter the settings of the change ratio. When we look at the slope test, front is ABC voltage, ABC current and voltage on the back. Based variability, according to the fundamental variability, total basic variability, and ramp wave content of each term. Determine whether the ramp wave is qualified. Current ramp polar variability is to judge the quality of the current waveform. It does not act as a judgment. The basis for whether the current ramp wave exceeds the standard. Does the current ramp wave exceed the standard? According to the national standard value, see if the absolute value of the current exceeds the standard. We are now looking at the IAS IBIC ramp wave. The instantaneous rate is relatively large, so let's look at the waveform. We leave only the current AIBIC. At this time, the waveform distortion of the current is more serious, so this means that the ramp wave of the current. Well, the total knock rate is relatively large, but does its slant wave value exceed the standard? There is no way to directly judge here. Does the current ramp wave exceed the standard? To be analyzed by software, check if each item exceeds the allowable value of the national standard. We want the test done. After the test is completed, click to stop recording first. Then the power is cut off. Remove the living part. Finally, dismantle the instrument wiring parts. And then we use proprietary software. For the software we store, the stored documents are analyzed.